So first step is 25% of 12, which is better known as 1/4 of 12, is 3. You got a whole number, that means you take that one and the next one. So take third and fourth, average those together. Average of those two is 31.5. It's right in the middle of those two. So when they're right next to each other, it's nice. It's just the halfway point. It's actually always the halfway point to average the two. Again, here, 2 steps. Half of 12 is 6. So I want the 6th and 7th. Next 7. So that's just going to be 39.5. Now, I'm gonna show you a shortcut, and then I'll do the long method for this one. 25th percentile was the 3rd and the 4th, right? From the bottom. 75th percentile is going to be the 3rd and the 4th from the top. 1, 2, 3, 4. I'm going to average those two. Why shouldn't 75% be symmetric to 25%? If you don't like what I just said, do this the same way. That's just a shortcut if you want it. So then what would that way be? 75% of 12. 3/4 of 12 is 9. So I want the 9th and 10th. And the 9th and 10th numbers are those two. How far apart are these? 3. What's half of that?
1.5.
Add that to 59, and of course I end up halfway. Right? If I go half the distance, I end up halfway. So that's 60.5. What is it? Yeah. Bam. Yes. Yes. Yeah. Because the first step is where's the answer, and the second step is go get it. Yeah. It's really hard to do it otherwise. Okay, so let me write this over here for myself. What was the lowest data point? 14. Q1 was 31.5. Q2 was 39.5. 3 is exciting, Jeff. 60.5. What was the highest one? 66. Let me take all this. What I just wrote over there, how many numbers are in there? 5. That's the 5-number summary. It's kind of like a football game or a basketball game or not. If you hate sports, it doesn't matter. Right? It's sort of like a set of 5 numbers that we just calculated. So it's the beginning, first quarter, second quarter, third quarter, the end. That's the 5-number summary. And then I can make this thing. Okay, the book calls it box plot. The official name of it is box and whisker plot. But if you want to be boring, you can call it box plot. Just to kind of show you, this is what it looks like. It's going to look like this. You guys might have seen something like that before. Looks like a piece of candy or something to me. I don't know. But yeah, it's like a cat with whiskers. That's why we call it box and whiskers. So here's how you do the box plot. What kind of scale do I need to get all these numbers to fit? I got to start at like 10, and I got to get up to like 70. So let's go by tens, right? 10, 20, 30, 40, 50, 60, 70. Good job. Okay. You guys ready? I'm going to put a line over each of these. So 14 is about right there. 31.5 is about right there. 39.5, 60.5, 66. Cool. The middle 3, that box off. That's the face of the cat. This poor cat sees through some shit. And then you put the whiskers on. If 2 of these repeated, you just end up drawing a line on top of itself. The book does it a nice way. They put a dotted line if there's two lines on top. So what am I saying? What if this was 14 and this was 14? How could that happen if the data was 14, 14, 14, 14, 14, 14, 14, other shit? Then it could be 14 and 14. They could both be 14. So if you want to go to draw the lines, wouldn't you have one line on top of the other one? So then your picture could look like this. Because your whisker is right on it's like the whisker didn't grow really, didn't come out of his face, it was on his face, right? And what the book does is they'll put a dotted line where there's an overlap. Okay, maybe. Maybe. All of these numbers could be exactly the same. What kind of data would make all of these numbers the same? If I have data where all the numbers are the same, all right. In which case I wouldn't draw a freaking box plot. It'd be a dotted line. It's like, thank you. So some methods for representing data I'm not going to use for certain data sets. They don't make any sense. They don't show me anything. Okay. How much data is in this box? What's in the box? What's in the box? Sir, don't open it. Sorry. No, the machine moved. Almost. I like it. What's this line here represent again? This represents the 75th percentile, meaning there's 75% below it. That goes too far, don't it? What was this line? 25th percentile. So what percentage is in the box? 50%. That's what we know as our heartland, the heartland of the data, right? If you look up college statistics, they'll often tell you the middle 50% SAT grades, here, the middle 50% GPAs, here to here, right? Maybe? No? Okay. So you'll often see that. Yes? Yeah, so that's what we just figured out. What percentage is in here? 50. Please let that make physical sense. If there's 75% below there and 25% below there, how much is in here? Subtract. No? If this is 75 feet and this is 25 feet, how long is this? 50. Okay. That's it. 75, 25. There must be 50 in there. Always, right? Because the box is defined to be from Q1 to Q3. So it's always going to be the middle 50%. So it's kind of like chopping off your overachievers and your underachievers and getting at the heart of the data. All right, so let's do this. You do that. You can work with somebody if you want to. As soon as we're done with this, we're going to head out. So you should be highly motivated.